Let us look at the what? The parameters of motion. Of motion. We have the parameters used in linear motion or rectilinear what? Motion include what we call particle. We have distance, displacement, we have speed, then we have velocity, we have acceleration. And we have time. So these are the what? The necessary parameters we use to describe what? Rectilinear what? Rectilinear motion or motion of an object on a what? On a straight line. So I would like to treat each parameters one after the what? The other. The first one we have particle. So what is particle? So particle is what? Is any object or body whose dimension can be neglected. Whose dimension, whose what? Dimension can be neglected is called particle. And it's always represented by what? By dots. So we use dots or points to represent what? Particle. So any object or a body whose dimension can be what? Can be neglected are called what? Are called particle. And the particle is always denoted by what? By point or dots. The next one is what? Is distance. Distance can be defined as the total length of part followed by body. Distance is what? Distance. Distance can be defined as what? The distance is the total length of parts followed by body. And the distance is measured in meter. It is what? Measured in what? In meter. And this distance is a scalar quantity. Is a what? Scalar what? Quantity. And distance of one revolution of one, we say distance of one what? Revolution. Distance of one revolution is 2 pi r. If you are talking of what distance of one revolution, the one revolution is this half of revolution, This is another half of revolution. So the total distance for a body to travel like this, this is the starting point A, end point is B. So this is what half of revolution, which is what pi. This is another half of revolution. So if we now combine the two together, we have it in this form to form a what? A circle. So in the circle we have what? 2 what? 2 pi. So the total distance cover for this circle, or total distance cover for this journey like this, is called what? What? One revolution. And distance cover for one revolution is what? Is 2 what? 2 pi, which is what? Perimeter of what? Of circle. And the distance of a moving object, or distance of a moving what? Object. Distance of what? Of moving what? Object can never be zero. Cannot what? Cannot be what? Zero. Can never possible for distance of a moving object to be what? To be zero. And again, for example, for example, for example, say a body, or move, a body move from point A to point C to point B. Then determine the distance. Yes, let us solve this. If a body start, assuming this point A is starting point, but the body now try to move from point A like this, get to this what? B, point B. Getting to point B, it will move to what? To point what? Point C. This is point C. From point what? Point A. And if the distance between point A and B is 3 what? Meter. And distance between B and C is 4 what? 4 meter. You are now asked to find the what? The distance of the body that moved from what? From A to what? Determine the distance of the object that moved from what? From point A to what? To C. So distance from A to C will be what? AC is equal to the what? From A to B. A to B plus B to what? From distance B to what? To C. So what is the value for, we are looking for distance AC. Value for AB. AB is what? 3 meter plus BC, which is what? 4 meter. Altogether, it will give us what? 7 meter. So the total distance cover for the journey of A to C is what? Is 4 meter. Have you now? It's 4 what? 4 meter. Another example. Let's say consider objects move along a closed circle. So if the object move along the what? The closed circle. The same question. That is for the same question here. We have A here. It's travel like this. Get to what? point B here, then it continues its journey to what? C. Distance between B and C is what? 4 meter. This is what? 3 what? Meter. But they said what? Consider objects move along a what? Along close what? Closed circuits. That when they get to the C, it's also come back to what? To A. Look at direction here. From A to B, B to C, C back to what? To A. And if this C back to A is what? Is 5 meter. Abi, you are now asked to find the what? The distance. What will be the distance now? The distance, total what? Total distance what? Cover, or total distance cover, which will be what? Distance of what? A to B plus B to C plus C to what? To A. You now have what? Our total what? Distance cover with what? AB is what? 3 meter. BC is 4 meter. 5, add it together. We are going to have what? 7 plus this is 12 meter. That will be what? Total what? Distance. For this one is open. But when this one is closed, come back to the A. Well, that cover is what? Is this. That is what? Distance. Or we can also divide distance as the what? Yes, you can divide as the what? As the total length of parts followed by the what? By the body. So the next parameters that are going to treat is what? Display what? Displacement. Now look at the word displacement. So displacement can be defined as distance in specific what? Direction. The distance of an object in a specific direction, we call it what? Displacement. Or displacement can be defined as a change in position of an object from initial to final. So the displacement, this is the what? The distance in specific what? Direction or direction or displacement is the, or this is the what? The change in position of an object from initial to what? Final. And the displacement is a, it is also measured in meter, but displacement is a vector what? Quantity. And this displacement, the distance, the what? Distance of one revolution of displacement is 0. For distance of what? Of displacement in a cyclic form, it should be what? 0. And the displacement can be what? Can be 0. Displacement can be what? 0. That's why we have it here. but distance of a moving object cannot be 0. But displacement of a moving object can be what? Can be 0. And let me use this as a case of what? This two example here for displacement 2. For this first question, that we agree that what? Object move from A to what? To B. Get to B into what? Into C. And the distance here is 3 what? Meter. Distance here is 4 what? Meter. Abi? So you can now that if you want to find what? Displacement here. Displacement of between what? This object to move from what? To this place. You can use what? Pythagoras theorem to what? To find the what? Displace what? Displacement. Like this. And to know the displacement will be what? A what? AC. Everything square equal to the what? 3 square plus 4 square. That should be what? To give us what? AC square equal to 9 plus 16. AC to be give us what? Square 25. The AC distance AC will be what? 25 what? Square. And AC is what? 5 what? 5 meter. If what? For display what? Displacement for this what? Question. But distance is what? It be 7. Can say that what? The displacement may be equal or less than what? Distance. And again, if you want to consider the what? This thing again, if it is what? It will be cyclic what? Cyclic form, like this. And then what do we have there for displacement? We have what? 5 what? 5 meter. Abi? For displacement is what? 5 what? 5 meter. So you are now asked to find the what? The displacement of this. If a body travel from A, no, do let me use this again. Okay, if a body travel from what? From A, yeah, and move to what? To B, getting to B, like this, and it get to back to what? From C to A. Here they said it's 3, here they said it's 4, here we have 5. You are now asked to find what? Displacement here. So your displacement here will be what? Will be 0. Because the body that is moved from A is come back to what? To the A. So displacement here for the cyclic will be what? Will be 0. Let's say what? Displacement for a revolution is what? 0. But for the convenience sake, let me use this this illustration as final example to explain the major difference between displacement and what? And distance. Look at it now. If a body travel from A like this, A, it will now move from A to this side. If the distance from A to what? To this point A, this point A, to this point B, this point B. Distance from A to B, let us call it what? 14 meter. And from this B to what? To C, point C, let's call it what? 5 what? Meter. And this body now move from B to what? To point what? D. And if this to point what? Another point D. Is that between C and D? Assume the distance is what? Is 4 what? 4 meter. So it's now go from this D back up. So this point here is called what? E. And distance between D and E is also what? 5 what? 5 meter. You are now asked, what is the what? Distance of the object that move from A to B to C, C to D, D to E. So here now, what will be our distance? Total distance cover. Distance will be what? From A to B, A to B, plus B to C, B to C, plus C to D, C to D, plus D to E, D to what? To E. So you have what? To calculate the what? The total distance covered from A to what? To E. D is it. Here, substitute for the each value there. What do we have? B, A to B is 14. BC, we have 5. DC, we have 4. DE, we have 5. So add it together. 10, 14, 24. Everything is what? 28 meter. 28 meter is what is distance of the body to move from A to what? To E. But if you are now asked to what? To find the what? Displacement. Displace what? Displacement. What do you mean the displacement? What do you mean the displacement? Displacement here will be what? A, for A to travel through this to what? To point E. That is, I say what? Displacement is what is changing what? In position. So for displacement, we are less concerned about what? All this total what difference, total distance covered. Our major interest here is what? Is A move to what? To E. This is A to what? A to E. You now look at what? What is the distance? Displacement is what? Change in position of an object. From initial, this is what? Initial. This E is what? Is final. So what is the difference between the initial and the final? That is our what? Major concern in displacement. So if this place for this place is what? Is 4. Here we also what? 4 meter. Subtract 4 meter from what? From 14. That is the displacement of what? Of A to what? To E, it will be what? It will be 10 meter. Therefore, displacement is what? Is 10 meter. So this is the good illustration for distance and what? And displacement. So the next aspect now is what? Speed, velocity, and acceleration.